This is actually a subject I take quite seriously, so the only problem, this is the only joke I think. That's all right. Come for jokes. Brian? Come on. The door is closed, we're ready to go. So that's me. This is my sensible engineering title. This is the NI marketing title. I didn't doctor it at all. That's me. There's loads of stuff there. I do work here. If you want me to do work in America, talk to them. Our dance female. Right. I like our dance female, and these two are very good, and it's very close to my heart. Xerox Park. Diana Mary, she did the bit block transfer, and if you like Windows, thank you, Diana. Windows, because she did the very quick algorithm that stops it all going in front of each other. And I like Adele because she did that. Because they had the small tool system, which was like the first Windows system, which is what you're seeing on your left. And she really didn't want to show Steve Jobs around. Really didn't. And that's how you get your Macs. It's all through theft. All the best stuff is through theft. So the goal of this, I hear it a lot, and I find this discussion of a programming language being fun to be kind of an interesting discussion. Because to me, it's professionals work, you know. I still like it, but it's fun. You shouldn't, you know, it's a weird thing. But this one, I've done this one before, but I'm more digging into the psychology of graphical programming. So this, if you're going to think you're going to take away useful sort of snippets of much, you're in for a disappointment, I'm afraid. Ask me if I care later. Hopefully this will help you, but actually it has, thinking like this, we're going to begin and has changed some of the design decisions I make when I'm programming, and maybe to do with the IDE as well, and design decisions from gentlemen who do that, and ladies. So starting off as a baseline, programming generally, and this is, if you all watch that, it's funny, but it's not easy. And to be quite honest with you, if you ever look at the Standish report, I put this up quite often, it's kind of an interesting set of graphs, because it hasn't really improved much. Now, we're all jumping on Agile, we're all jumping on all these various latest things that are going to solve, you know, all the silver bullets are going to solve all our problems, and then you look at the graphs. Now, it's kind of skewed, because it doesn't take into account projects getting more complex. I think projects actually race slightly ahead of the capabilities. I think you're always here. So I think that it actually skew that to complexity might be interesting. But I like LabVIEW. And why is that? Because I think LabVIEW is different. I think LabVIEW is a step forward. And I've come from programming lots of programming languages, so I'm not biased, typically. And I think it comes down to this. And this is all part of the immediacy part of my thing, is that it's a good talk, disappears. You don't think about the talk, you don't think about the idea in a good idea. And then it really helps your brain. So, to emphasise this, I'm going to go through this video, and this is what I want to sound for. Actually, I won't do the first one because that just makes me do it. I'll do a horrible Californian accent. But this guy called Brett Victor, he's very into the Apple sort of iPad UI design. He's very into sort of software design. What he's looking at now is the interaction of the software design. And one of his sort of main areas really is to do with JavaScript and making an interactive programming language. And that's got millions of views, millions. It's highly influential. And you look at it, so I won't do his intro, but he's very big on immediacy. And what he means by that is this. You see why I didn't want to do taxes.
Can you put the mic by them?
Okay. Okay. Ignore that then. So essentially what he's saying, I'll mime it for you. What he's saying, standard way of doing code, do it in text, you make a change, you have a look at it. That's the text placement language way of doing stuff.
Can you redo it with the accent, please?
I'm so tempted. I did practice it as well. But so what he's now done is done this book language type thing, and you can actually tap in data, and all of these changing stuff on the fly in the language, all on the fly. But the thing is, that's all bullshit. That's an absolute, it's just bullshit. Those there are doubles. You can see he's tapping in, you bring up the little slider and he goes, oh yeah, you put in your slider and it makes the branch length up and down. Well, if it's a double, that slider is going to be plus or minus 2 billion, isn't it? So straight away the slider must know it's a branch to be able to do that. Oh, hello. Quit stuff in there. So the fact is, this is desirable, and this, when he showed this, he presented this, the whole crowd went wild. Woo-hoo, and it was whooping and dancing in the streets in the world of JavaScript.
You're saying it's bullshit because his example is already contrived to be in the space he's trying to demonstrate.
Yes.
Okay.
It knew the context it was working in.
All right.
So he had to have written it as a tree context, as it were, to be able to interact with it. The idea is not bullshit, but the execution that everyone... So they all went roaring off and tried to make this interactive booklet, and of course it turns out it's quite hard. Except, and I put hours into this. This is... Hello, Nancy. It's quite handy, actually. I wanted to attend to a presentation. So if you hear me phasing out, then... There we go. There it is. We've got it already. It took me ages to do this, and I showed it the first time, and everyone went, oh yeah, I know. The crowd did not go wild. But it's there. This is the most desirable thing for a lot of these people. It's there. This immediacy between the thing we're looking at and how we're programming, the way we program. So when people whinge about LabVIEW, try to use this JavaScript. They get very excited about this. The hours I put into that was one sentence worth of complaints. So, going to jump now. Miller's law says you can only think about 7 things at once. They do a psychology test, and they throw numbers, musical tones, pictures of cartoons at people, and then ask them to read them back, and pretty much everyone can read between 7 and 9. You get context experts like musicians that can read thousands, but they're freaks. Normal people can only do between 7 and 9. Keep that number in mind, it's important. Now, when you do user interface design, this is very important. Now, I haven't really pushed it into this, but I think when you do your program design, your block diagram, you should perhaps apply some of those user interface rules to your block diagram. It's coming soon in a presentation when I can read books and stuff. So, a programming environment conveyed the experience of immediacy drawing the program. This isn't the world of LabVIEW. This was me going through what little computer science there is. So we do a cause and effect. This is how we get to this immediacy. So enabling reflection action. Back talk is a necessary condition for reflection in action, just as immediate feedback is a condition for flow performance. Going off into the next bit of psychology. Flow state. So flow state means, okay, so that's me saying that. So it's me, he, chick, sent me. I apologise for that. This guy here, he deals with musicians, and he's very interested in this flow state that people get into. Now, in the world of sports science, very interested in it. And what it is to do with, there's a point in time when you're working that you lose all track of time. And you come out of your program and you think, oh, I've missed dinner. Or for me, what I get is a physical thing. So I don't swallow, and I get ulcers in my mouth. But it's like I'm so engrossed in what I'm doing. And there are actually studies that say it's flow really effortless. Do you get a benefit from being in that state? And what they've done is they've stuck people on their heart rates and their eyes and their heads. And what happens is your eyes focus. Your eyes don't move around, they focus. Your breathing goes down, and something goes on in your brain. Concentrating stuff. But essentially what it means is that you get much more bang for your buck. You're getting a real payback on this state. And this is how you can actually achieve more and more. And what it has to be is that it can't be too hard because you get frustrated, and it can't be too easy because you get bored. So in the middle, you have a point where it's matched. So your tools you're using, the way you program, and the challenge of the program is matched. And when you reach that point, you get to this flow state, and it's very linked to happiness, it's linked to being able to work hours without being tired. It's quite an important thing. But what it also allows you to do is fit more stuff in your head. So your 5 slots become 9 slots, and then you can start visualising bigger problems. So previously, if you've ever seen any of my presentations, I talk about cohesion. People talk about solid principles and various other design techniques. The whole basis and foundation for all of those is to fit more stuff in your head. You know, that you're trying to visualise more and more complex problems. So this is actually back from coupling cohesion information, and for me, and solid Uber types. And going further into this, again, this is coming from Brett Victor. So he's done, out of everyone, he's done probably the most work I've found. And it's to do, and I thought this was very applicable to LabVIEW. This explanation out of context and explanation in context. Well, LabVIEW's always explanation, or should always be explanation in context. You're looking at the graphical representation of the thing that you're doing, which is much better than words, in my opinion. And going back to the user interface thing, and again, this is something I'm going to have to get up to speed on a bit more, is I think a program is your user interface to your solution to the problem. So you need to apply those rules. And if you read the books, there's actually some good computer science on user interface design. There's things like signifiers which lead you into how you do stuff. You know, your wizard where you've only got 5 or 6 things on it. That kind of stuff is what we should be thinking about in our block diagrams as well. And again, it comes down to coupling cohesion. Well, that's the reason for it. So again, rather than plan out everything, we experiment. And remember all the details, it's just as easy to test. This is again, reasons I like LabVIEW. What the language is dynamic enough that it breaks the traditional programming paradigm. And that, to me, is in the last 2 or 3 years, the areas I've been thinking about with LabVIEW is that we're very keen to apply rules, for example, to reuse. And And I'm not entirely sure that if you have a language this dynamic, you need to apply the rules quite as hard as we do. And just to show how cutting edge my ideas are, looking at the LabVIEW 1.2 manual, this is our the beast. You know, it says, give it a try, experiment, let's see what it's like. I like that, I thought it was great. So the 5th edition of LabVIEW Graphical Programming, this is a nice little quote from it. Most engineers learn about an instrument by studying its front panel and experimenting with it. Look at its mouse, menu, scroll, blah, blah, blah. And they're just talking about instruments there, but I would say at any point if you can do that, that's an advantage. So there's different types of immediacy. So by immediacy, I'm thinking, got a figure block diagram. I need to be able to flip to it quick. So if I've got a problem, I need to be able to flip to the solution. I'm moving around quickly. So temporal immediacy is one area. So it's the really difficult bug that doesn't show itself immediately when you run it. So, you know, and quite a lot of distributed systems sort of suffer from this. Is you'll do something and then, I don't know, 20 seconds later it'll go bing, and you'll think, oh, that's because I pressed this button, but actually it's because you pressed 15 buttons before or something like that. So again, it's that kind of thing is very hard to capture. Spatial immediacy is, again, going down to coupling. This is the spatial immediacy. It's the physical distance between a causally related event, and it's kept to a minimum. So I sometimes find abstraction layers frustrating. And that's the reason you find them frustrating, is because you see a issue, so you see a number, and down about 25 layers is the thing that causes that issue. So it's a layering thing. I think they call it a spaceman architecture or something, but it's to do with, it's a long way away from cause and effect. So there's a real benefit by making the cause and effect as minimal as you can. I mean, the abstraction layer is always going to have layers, but there's a design requirement just for your own lack of frustration not to go digging around stuff. I'm throwing out a lot of words here, and there's a big grouping of them, but I think the text-based language is a platonic thinking thing. You think of a theory, but you don't bother testing it, and you compile, and it all goes wrong. Whereas LabVIEW programmers, we're all experiment, see it works, experiment, see it works. So again, this is Martin Fowler. He's talking about conversational software. And these are all, the reason I'm chucking all these words up is because I think they're all describing LabVIEW. Whether we hang off any of them or none of them, I think these are all words that describe LabVIEW. So, the conversational software. I sit with my customers and I'm doing programming with them on the fly, showing them new stuff. And you don't get that in other languages. It's very hard to do in other languages. So this is a completely different way of programming than any other text-based language I've tried. You just don't get that. Even if it takes 20 seconds to compile every change you make, it just doesn't work when you're sat in front of a customer. So it's involving the user in the process. And I still think this is about the most agile way you can do something. You sat down with the customer, doing it straight away. And we learn as we go, and that's also good for me. Because if I'm sat with a customer and I go, click here, click here, click here, click here, click here, and he's going, no, that's not our process. We want to do this, do that, and the other. I'm learning more about him and his process, or her process. So yeah, again, I'm quite tactile, so when I'm designing a user interface, I want to see pretty much immediately how it changes it. So, drag and drop. So you've got two ways of pushing data into something. It could be a list box and a button, or you can drag and drop. Which is best? well, I can just try it and see which ones the customers like. You know, it's not actually, you're not defined by it. And I like to think of myself now as a designer. And the cause and effect brain, that's the important thing for me, is that's how I work. I'm reasonably sure most other LabVIEW programmers work that way as well. So again, another word, constructionism. And it all links back, funnily enough. So constructionism is this practical thing for kids where they actually learn by doing. And oh look, it's Mindstorms. It's all, so I wonder if was it called Mindstorms because of constructionism? I wonder if it was. Right, tell me. So how do you break flow then? And that's the thing, that how I work really, is I think, well, this is annoying. This part of my program is annoying me. So why is it annoying me? Why is... And I did this in my lean LabVIEW. And there are things that you can do to your LabVIEW program which hinder LabVIEW from getting me that immediate response that I want. And so I was debugging a system for MPL, and it loved re-entrancy. Everything was re-entry. And it was just a pain in the neck. And everything was dynamic, and I couldn't see how it worked. And that annoyed me. So what I'm kind of asking for from a design perspective here is use them. You know, all these things are useful, they have uses, but don't use them everywhere if they're not useful, because there's a cost, there's a sacrifice. And the other annoying thing for me is context switching, and it's just a tiny little subject this year. I've been talking to various people about this. I want to push everything from the block diagram. I want to work in the block diagram. That's my canvas. Take Darren's, take his work. That's where I work. And I don't want to move out of that, because once I've moved out of that, I've context switched, and there's another couple of little slots in my brain gone, being used, because I've just gone from fault finding to searching. And again, hierarchy is one of those issues. If it's too far down, it causes a problem. So there's a balance to the layers you put in, and how annoyed you get when you go looking for stuff. And I really am. I'm a block diagram fundamentalist. Everything should go from the block diagram. And from a tool design within LabVIEW, I want to right-click. I mean, the context zoom thing, semantic zoom, I'm so excited about this, because I can go right-click, go to whatever I want. That's how I view that. And I want it to be a right-click, go to wherever I want, or a double-click, or whatever. So this is what I mean by semantic zoom. And I bothered poor Jeff with this. Please do it. Oh, I don't know what I was saying. Right. So, essentially what I would like, in the block diagram, this is a state machine diagram. This is a state machine. So I want to be able to put things onto the block diagram, and then I want to... I think I'm talking about this. So if these are graphical objects on the block diagram, I then want to be able to zoom into the code and then zoom out again. I don't want to go to a tool that is the state machine toolkit, which is another screen and another whole paragraph. And I think this is possible. It's ambitious, but I think it's possible. And I think, and I'm not expecting it soon, I'm just thinking this is how we should be thinking. We should be thinking about how can we keep and stay in the block diagram as much as we can, and not keep jumping around in different parts of the screen. Because now I'm doing state diagram stuff, and very easily I'm zooming in and doing the state stuff. And I did that when I was drunk. That's how creative I am. Big crack off. Big crack off after a few drinks. And going back to sort of LabVIEW in its most simple form, and this is actually a way I've modified the way I work. and it's probably interesting to other people, is that that's LabVIEW at its best. It's dirty, it's data in, data out. This is where LabVIEW does everything as best it possibly can. And what we then do is we, I don't know, in our case, we would have a queue and take it from a database, so, and then to good cohesion, we'd make that one module so that you press it, oh, I've got my data, and now I'm doing this, and I come out with a number. Well, actually, that's not what you want to do. Is the bit with the algorithm, keep it in its most editable form, the best way to use it in LabVIEW. All the carrier stuff, like the classes and things like that, they just leave them out, but separate the stuff that you want to see the data in out. That really saves me a lot of work. And I now split things out so that they're just essentially empty shells. I do all my, I don't know, for a database thing, I get my data, fill in my empty shells, and then just open them up and get them to manipulate as I want them. And it's just a nice way of working. And you can experiment and test it. So, it's a functional VI, but I don't want to really get into the argument of functional VIs. It's another religious war that's brewing. So I quite like the term immediately testable. It's okay, I can immediately test it, I think I described it. And non-runnable as wrappers and carriers for immediately testable VI. So you end up with a project of things you need your whole framework to run, and then all your stuff that's immediately testable. And splitting that out has been a real benefit to us. What do we do for time? So going back to the sort of user interface rules, we often use signifiers, and signifiers, so I come across quite often a lot of programs where all the references are on the side, and all the indicators and controls are on the side in a big sequence, and then I just put all the references into a big functional global, and that's the way they work. And it's a shame because it's really quite useful just to pop them into their event. So you go right click, oh, I'm there, so you can actually use the controls themselves as your signifier to allow you to navigate your code. So things like that are, again, coming from this sort of user interface rules, is, they're there, they're floating around in your block diagram, so you might as well use them for something, and if it's to get you to the bit that's interesting to you, bonus. Searchable, again, searchable's good, use the navigation tools, use the search tools. I quite like the constant VI as a good example of a search tool. And the thing about this is it's allowed me to go and have the confidence to go off and do stuff in different areas. Because I can see the data. I'm not scared of it, I'm not, and so we started off, essentially I started off at the top of the pyramid in aerospace, commercial test, transducer test. Don't do any of that anymore. It's boring for me. So I'm down in this bit in the machine monitoring. It's much more fun. And I wouldn't have got there really, that wasn't my training, but I wouldn't have got there without LabVIEW really being the tool that allows me to experiment. So that's one of the reasons I quite like it. And that experimental stuff is very useful for that sort of expanding your knowledge. So here's a load of terms. I don't know which is good, which is most interesting, but it's ones that I quite like us to talk about because I think it's important from a design criteria to start thinking about this in the IDE, and I think flow is important. I think it's very undercooked from a computer science perspective. Computer science doesn't, that's what I told you last year, I don't touch LabVIEW. Just don't touch it. And it's a shame. They don't touch graphical programming really. It's a shame because going back to that that graph of improvement, LabVIEW would make that improve if it's done correctly. So, to me, and I'm early again, it's 2 I'm done early. So LabVIEW's number one advantage is its immediacy. I think, this is in my opinion, all of this is my opinion, sample one. The iteration of rapid debugging is actually a more natural way to program, for me. I'd like to think for more people than me. The IDE lets us explore different domains. We can make our lives easier by splitting on mobile. We can leverage this by thinking about navigation and searching. And we should consider user interface rules when creating our block diagrams to help our brains. So, yeah, I'm going back to the computer science thing. I think we may need to go it alone. I don't know I don't know what the answer is really, but I think for a lot of this stuff, a lot of the psychology stuff, we may just have to sort of try and survey each other and work out what we do and learn from it. I mean, that's the other thing with LabVIEW is we all do it different ways, and that's cool. You know, but it's interesting also, you know, it's what benefits and what sacrifices we make in each of our design decisions. So if you want to hear me talk about state machines, you can see me at GCAVCon in Birmingham. I've got a date there. And maybe a day before doing a workshop. Well, we'll be doing a workshop, not May.
We will.
What? She's here. Jeez. We will be doing a workshop on the 20th, and it'll be amazing. Blah, 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 survey, blah, 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 blah. I moaned at NI because they wanted me to do... I kept going, oh, can you put this extra slide? Oh, can you put this extra slide in? And I said, you're fully 10% of my slides now. Advertising various things. Yeah, thank you. And that's it. And I know this is not your standard sort of LabVIEW thing, but I like it. This is more interesting to me. Huh? Even better.
You said no laughing, so I'm going to ask you next question.
Oh, you know.
What is your process of finding the right balance between
Our model is you go for the simplest solution immediately. If you're sat there doing it, you think, oh, that's a bit of a worry. What happens if they're likely to change?